So this is where we are with our current data logger setup using the ESP32 Bluetooth enabled microcontroller and the Arduino IDE. So you can see here in the serial monitor we have the ESP32 is waiting for the start command to be sent via Bluetooth, so we can do that now. This is the Bluetooth control terminal, and I've already defined here a start button. The first thing we need to do is connect, so just tap up there. I'll tell you what's connecting, it's connected. So if we press start, it says logging started. So let's have a look at the serial monitor. Every second we are getting a reading, so it's about milliamps, 0.1 milliamps, and there's the time. So if we scroll down, set that to view new data, the current in milliamps is about 1 milliamp. It seems to have dropped off there, maybe my battery's not properly connected. This is the 9-volt battery that we've got just taped on there with some jumper leads. It is 9 volts, and that's going through a 10,000 ohm resistor and then to an INA 219 current sensing chip. And the data that's being read from the chip is passing to the ESP32 microcontroller, and then from that to the SD module with an SD card in, saving that as an SD file, as a CSV file, sorry, and then allowing me to export that through the Bluetooth terminal. So you can see here, current in milliamps is about 1 milliamp, more or less consistently over time, 1.2, 1.4, 0.9 there. So that's around about consistent with what Ohm's law would tell us. If we have a 9-volt battery passing through a 10,000 ohm resistor, it should be about 0.9 milliamps. So if we look at our serial monitor again, 0.9 to 1. Yeah, I mean, it's not brilliant. It's not exactly 0.9, but it's close enough. So we can see I've just disconnected the INA 219 current sensing chip, and I've plugged my calibrated fluke multimeter into the breadboard where the INA was. So according to Ohm's law, 9 volts at 10,000 ohms should be 0.9 milliamps. Now, it's not exactly 0.9, 0.96, but between 0.8 and 0.85 and 0.95, it kind of jumps around a little bit. This fluke is more accurate than my setup that I've got, so it definitely still needs some work, but we're on the right track. Here we are at the next stage. We've just swapped out the 10,000 ohm resistor for a 100 ohm resistor. So 9 volts at 100 ohms should give you 0.09 amps or 90 milliamps, and we're getting readings of less than 90 milliamps. It's 77 milliamps, 78 milliamps, something like that. So let's check the calibrated fluke now in the connections where the INA currently is, and see if it's around about the same 0.76 to 0.78 amps, or if it's 90 milliamps. Here we are, we've just got the multimeter positives and negatives plugged in exactly where the INA 219 was, and if we look on the screen here, Ohm's law says it should be 90 milliamps, but I mean that battery might not be exactly 9 volts and the resistor might not be exactly 100 ohms, so I mean give or take a little bit. But if you just look at the results we're getting, they're round about the same as what we were getting with the INA 219 on the serial monitor. So it's about 70 milliamps, changing over time slightly. I'm quite happy with that. And you can see that's just gone more or less to zero because it's obviously disconnected.